In today's class, we will learn how to write inductance of single phase two-wire line. Okay, inductance of single phase two-wire line. So two-wire line means there are two conductors, conductor 1 and conductor 2. So one conductor will be called as forward conductor, who will carry current plus I, and the radius of this forward conductor is your R. The other conductor is your conductor 2, which is actually return conductor. Okay, this will provide the return path for the current. So this conductor, return conductor, we can say it is carrying minus I current, means I plus minus I plus minus I must be equal to 0. Okay, so we have assumed both conductors radius equal to R. Okay, both are of same radius, and D here you can see D. This D is your center to center distance. Okay, so now we will talk about the first conductor. Okay, so we will write we will write the inductance of first conductor, and then we will write the inductance of second conductor, then we will add the inductance of both the conductor, and we will get the total total inductance of the loop, or summation of inductance of both the conductors. So for conductor 1, what is, if we write like this, that inductance internal, we have learned how to write internal inductance and external inductance in our previous videos. So for conductor 1, if we write L internal 1, means internal inductance of conductor 1, we know this, the value of this is 1 by 2 into 10 raised to power minus 7 mu r1. Mu r1 I am putting because of the conductor 1. So this is in Henry per meter. Okay, what will be L external? L external of conductor 1, we have derived this in our previous video. It is 2 into 10 raised to power minus 7 ln d by r. This one also in Henry per meter. So if you add this both L internal and L external, so what you will get? L total of one conductor, means first conductor, and you will get 1 by 2 into 10 raised to power minus 7 mu r1 plus 2 into 10 raised to power minus 7 ln d by r. Okay, this much Henry per meter. Similarly, for the second conductor, you can write L internal of second conductor, which is equal to half into 10 raised to power minus 7 mu r2. It will be in Henry per meter. L external of conductor 2, 2 into 10 raised to power minus 7 ln d by r, where your d is center to center distance between the two conductors. It will be in Henry per meter. So L total of second conductor is L internal plus L external, that is half, into 10 raised to power minus 7 into mu r2 plus 2 into 10 raised to power minus 7 ln d by r. Okay, in Henry per meter. So what will be L total? L total means for both the conductors. L total or loop, we can say L total or loop. Okay, one is forward conductor and other one is a return conductor, so it will form a loop, a closed circuitry. So L total will be L total 1 plus L total 2, L total of one first conductor plus L total of second conductor. So you will get half into 10 raised to power minus 7. You will get mu r1 plus mu r2 plus it will be 2 times of 2 into 10 to the power minus 7, so it will be 4 into 10 raised to power minus 7 ln d by r. It will be in Henry per meter. So for non-magnetic material, your mu r1 is equal to mu r2 is equal to 1. So simply you will get half. This half will get cancelled out with 2. Mu r1 plus mu r2 2, so 2 will cancel out. So it will be 10 raised to power minus 7 plus 4 into 10 raised to power minus 7 ln d by r, Henry per meter. Okay. If we take 4 into 10 raised to power minus 7 common, so you will get simply 1 by 4 plus ln d by r. No problem. It will be in Henry per meter. Okay. So you can write like this. It is 4 into 10 raised to power minus 7. 1 by you can write 1 by 4 as ln e 1 by 4 plus ln d by r. Okay. Further simplify it. You will get 4 into 10 raised to power minus 7. It is ln a plus ln b, ln ab. So it will be simple ln e raised to power 1 by 4 into d by r. If you further simplify it, you will get 4 into 10 raised to power minus 7 ln d e raised to power minus 1 by 4 into r. And you know the value of e raised to power minus 1 by 4. It is 0.7788 into r. Okay. So the final expression is 4 into 10 raised to power minus 7 ln d by r dash. Okay, this is your L total. L total means both for both the conductors, and it is in Henry per meter, where your R dash is 0.7788 R. Okay, so we can say that this value of L total uh, is actually twice of the inductance of isolated conductor, or we can write like this: inductance of isolated conductor is one half of single phase write like this: single phase two wire system. Okay, so in isolated conductor, your inductance was 2 into 10 raised to the power minus 7 ln d by r dash. Okay, now uh, suppose the radius of the two conductors are not equal, means they are different. So what will be the scene? So in this case, you have you have to you have two conductors of different radius. So let the radius of first conductor, and this one is the radius of second conductor, and the radius of first conductor is r1 and radius of second conductor is r2, and the spacing between these two conductors is center to center distance is d. So in this case, what will be L total? In this case also L total will be the summation. L total will be your summation, that is L internal of both the conductors plus L external of both the conductors. So L interval will be same constant value. Write L external first. L external of first conductor, or simply write L external means summation of two. For first conductor it is 2 into 10 raised to the power minus 7 ln d by r1. Okay, and for second conductor it is 2 into 10 raised to the power minus 7 ln, here your radius is r2. Okay, so take common, 2 into 10 raised to the power minus 7 as common. So you can write like this: ln a plus ln b means ln a into b. So d into d, it will be d square, and r1 into r2. Okay, now we can write as 2 into 10 raised to the power minus 7 ln d. If we write like this, under root r1 r2 and whole square, it's the same thing, no problem. Now you can take this 2 which is in the exponent. Okay, Now you can take this 2 into multiply. Here you will get 4. 4 into 10 raised to power minus 7 ln d over under root r1 r2. Okay. Now, so it is your L external for both the conductors. What will be L internal? L internal for both the conductor. You will sum it of half into 10 raised to power minus 7 into mu r1 plus half 10 raised to power minus 7 into mu r2. So add it, you will get half. Half will get cancelled out. It will come as, okay, now half into 10 raised to power minus 7 common mu r1 plus mu r2. This will be your L internal. So now write L total. So your L total will be L total L internal plus L external. So it is your half 10 raised to power minus 7 into mu r1 plus mu r2 plus, this was your L internal, and L external is your, add it and you will get 4. 4 into 10 raised to power minus 7 ln d by under root r1 r2. Okay. So now we will write for non-magnetic material. For non-magnetic material, mu r1 equals to 1 and mu r2 equals to 1. So in that case, L total will be how much? 10 raised to power minus 7 plus 4 into 10 raised to power minus 7 ln d over under root r1 r2. Okay. So if you take here 4 into 10 raised to power minus 7 common, so you will get 1 by 4 plus ln d over under root r1 r2. Okay. So on simplification you will get 4 into 10 raised to power minus 7 ln d e raised to power minus 1 by 4 into under root r1 r2. Okay. So further on simplification, you will get 4 into 10 raised to power minus 7 ln d. If you put this e raised to power minus 1 by 4 inside the square root, so you will write it 2 times. So you can write like this: e minus 1 by 4 into r1. Okay. again into E minus 1 by 4 into R2. Okay, no problem. So 4 into 10 raised to power minus 7 ln d. This E raised to power minus 1 by 4 into R1 is your R1 dash. Okay, and E raised to power minus 1 by 4 into R2 is your R2 dash. It will be in under root. Okay, so now we can finally write as 4 into 10 raised to power minus 7 ln d over r dash, and this will be your L total. Where I will write where r dash is your how much? Under root r1 dash into r2 dash. Okay, and what is r1 dash? Sorry. And what is r1 dash? And r1 dash is your 0.7788 times r1, and r2 dash is your 0.7788 r2. Okay, so this r dash is also called as GMR. GMR of system. GMR means geometric means radius, and this D will be called as GMD. GMD of system. Okay, so now let us, for your homework, I'm giving a problem which was asked in GATE, okay, in previous year. The problem is, consider a long two-wire line is transmission line composed of solid round conductor, solid round conductor. The radius of both conductors is 0.25 centimeter, and distance between their center is 1 meter. If this distance is doubled, the inductance the inductance per unit length, first option, doubles, first option is your doubles, B halves, C increases but not double, and D decreases, sorry, and D decreases but does not halves. So try to solve this problem. Okay, thank you for watching.